Okay, in short run, basically, labor is a variable input. Okay, labor is a variable input, while capital is a fixed input. So you guys know this from our earlier recording that there are some variables which are some inputs which are variable and some inputs which are fixed. So we'll assume this, that capital is fixed. You can't change building, you can't change machines and some other kind of capital, but you can change labor. Since the labor is the only endogenous variable, labor is the only variable which you can change, that's the only choice which is open to you, then this is the only thing which can help you in efficiently produce your output. So your key question should be how many workers you should hire in order to maximize your profits. Okay, so and the key variable here would be your MPL. MPL is basically change in output due to the change in labor, keeping capital constant at K bar. Okay, so for example, when you're using say 5 units of labor, okay, you're able to produce 25 units of output. When you increase the amount of labor to 6, you're able to produce 30 units of output. So that's plus 5. So output has changed with 5 units as employment has changed by 1 more unit. Okay, so this is the marginal product of labor. Okay, well, but remember that you're assuming that marginal product of labor will fall. Okay, it will have a diminishing return. Okay, well, you are saying this, that fine, you go to 7, then the change in output is just going to be 4, which means that increase in output is just 4 with an additional worker. So when employment of labor changed from 5 to 6, output increased by 5 units, as you could see. When employment of labor further changed from 6 to 7, output increased only by 4 units, not by 5. So this is the marginal productivity. This is the total output, okay, which is say Q or whatever, and this is the labor. This is the marginal productivity of labor. As you've seen that marginal productivity of labor is falling. So you've assumed this, that marginal productivity is diminishing. That is, every additional worker, adds less and less to output. Adds less and less to output. The question is why? Why are you assuming this? The reason is because you're holding capital constant. You're holding capital constant. Okay. Now, since you're holding capital constant, it means that these workers, they have to work. Say, for example, capital, in your case, capital is just land. So there's only 1 unit of land. Even 5 workers have to work with only 1 unit of land. 6 workers also have to work with only 1 unit of land. 7 workers also have to work only with 1 unit of land. So of course the productivity of labor will fall. Okay, you're holding the other variable constant. Okay, this is the reason that every additional worker, it adds less and less to output. Okay, other important point is that in long run, what happens, that labor is of course variable. You can change this. But even capital becomes variable. Labor is of course variable, but even capital becomes variable. You can even change capital. So you can definitely choose both capital and labor. In the short run, it was only labor which you could choose. But in the long run, you can choose both capital and labor. Say, for example, your production function is of this form. Q is equal to root of KL. Okay. Now, this production function, this is the relation between the inputs and outputs. So, that is the maximum amount of output which you could produce with a given amount of inputs. So it shows the different combinations of capital and labor which could be combined in order to fetch you a given amount of production. Say, let me make my life simple by just drawing this diagram. Q is equal to KL. Q is equal to KL is supposedly a production function. And I fix Q at 10. So now I need to know different combinations of K and L, which will give me Q equals to 10. Remember that I have to fix Q at equals to 10. So K could be 10, L could be 1, L could be 10, K could be 1, L could be 2, K could be 5, K could be 5, L could be 2, K could be 2.5, L could be 4, L could be 2.5, and K could be 4, and so on and so forth. So there could be different combinations of capital and labor which can fetch you the same amount of output which you want. So this is isoquant. Isoquant is that you fix your production. That is the different combinations of labor and capital along which production is same. Now isoquants, they are completely like indifference curves. They're completely like indifference curves, that is, and they share almost the same properties of all the indifference curves. That is, this is your labor, this is your capital. So, this is an isoquant. Say, for example, Q naught. So, all the combinations on this curve is giving you the same amount of output, Q naught. Well, the important property is, of course, that further out the better. In case isoquants have the preference direction of this northeast. So in case if this isoquant, Q1 isoquant, is better than Q naught isoquant, because with a given amount of capital and labor, you're producing more amount of output. So, okay, so this is better. Now, other is, of course, they can't cross, and they slope downwards. Why do they slope downwards? Because this involves the trade-off between capital and labor. This involves trade-off between capital and labor. Say, for example, if you are at this point, okay, let me just draw it more properly. Let me pick up a thin line. It was not as thin as I thought. So this is K1 and this is L1. Okay. Oh, my paintbrush has gone thin, but my line brush is still that. Okay. Now, supposedly if I move to this point, okay, so it is K2 and this is L2. So this is, say, point A and this is point B. So at point A, as you could see, the amount of capital is more with you and the amount of labor is less. And when you move from point A to point B, you have made a trade-off. You've made a trade-off between capital and labor. You are giving up capital. You're reducing the amount of labor, capital, in order to get more amount of labor. So there's a trade-off which is happening. And that's the reason they slope downwards. And what do you think determines the slope of an isoquant? It is basically substitutability. Between capital and labor. So it is substitutability between capital and labor is actually going to determine the slope of an isoquant. In case if there is no substitutability whatsoever, say for example, perfect complements kind of an isoquant or a Leon type function kind of an isoquant. So where Q is equal to say min of KL. So you have to use this much amount of capital and labor in order to give you a given amount of Q. Okay. It's not that you can have more amount of Q, more amount of K and less amount of L, and that will also fetch you the same amount of Q. It won't. Okay. So these are perfect complements. They have to be used in a fixed ratio. There is no substitutability at all. Okay. So another case could be you're perfectly substitutable. So for example, Q is equal to K plus L. You're just concerned with the sum. Okay, if K could be 0, L could be 10, L could be 0, K could be 10. You're just concerned with the sum. They're perfectly substitutable. Okay, so the point is that in general you will be lying somewhere between them. Okay, so there is no substitutability at all. There is perfect substitutability. Okay, so there is perfect substitutability. Or even infinite y1. There's infinite substitutability. I'm sorry, why I'm writing 1. So there is infinite substitutability. They're perfectly substitutable. So, and in general, you would lie somewhere in between them. Now, this leads us to the concept of an MRTS, that is marginal rate of technical substitution. Okay, marginal rate of technical substitution. So how much of labor you have to give up in order to get an extra unit of capital, or how much capital you have to give up in order to get an extra unit of labor. Okay, along an isoquant. So, and remember that your MRTS is going to change along an isoquant. Okay, so let me just draw this for you guys. So you have labor here, you have capital here. And supposedly if this is the point, this is one point, this is another point. At this point, you have basically more capital and less labor. Okay, at this point, you have less capital, more labor. And MRTS is basically the slope of, MRTS is nothing but the slope of an isoquant. As you could see, the slope is changing. As you could see, these slopes are changing. Okay? And MRTS is of course, it's not constant along this kind of an isoquant. Okay, and at this point, you're basically capital intensive. While at this, you're labor intensive. So this marginal productivity is, MRTS is falling, okay, as you go down. And what is driving this? Diminishing marginal productivity. Diminishing marginal productivity is driving the reason that why MRTS is falling as you go down. Okay, so well, this was some of the concepts related to production. That is, and we'll go a little deeper into it. Okay, in the next recording, we'll talk about what exactly are returns to scale.